everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, Pure Mathematics 1 for May-June 2022, and the code is 9709/12. Okay, so remember to subscribe to the channel so that you will get notified on the new videos. So let's move on to question number 1. Question number 1. The coefficient for x degree 4 in the expansion of 3 plus x degree 5 is equals to coefficient for x squared in the next expansion. Find the value of the positive constant a. So basically 3 plus x degree 5 is equals to x plus 3 to the power 5. And this is same as summation 5r x to the power r 3 to the power 5 minus r, whereby the r starts from 0 until 5. Okay, if I need to get the x degree 4 here, that means, alright, it will be x degree r. So obviously the r equals to 4. So the coefficient for x degree 4 can be found when the r equals to 4. So it means that here, coefficient of x degree 4, it will be 5c4, 3 to the power 5 minus 4. Which means this is going to be 15. Okay, so now for the next expansion, 2x plus a over x to the power 6. This is going to be summation 6r 2x to the power r a over x to the power 6 minus r. Then the r starts from 0 until 6. Okay, so from here I can split it again because you have more than one term with the r there, with the x there. So here this r will bring in to the bracket, then I will get 2 power r times x power r. Then this 6 minus r bring into the bracket as well. So a to the power 6 minus r. Now your x is at the bottom, I will move up. That means it's x power negative 1 to the power 6 minus r. Okay, so now we need to get coefficient of x squared in this expansion. So x squared equals to, now when you compare, this is x degree r together with this, then I will combine. So now I will get x degree r multiplied with x. This negative 1 you times out, it will be negative 6 plus r. Okay, so we have a formula here. A to the power of m times a power n, it will be a to the power of m plus n. Okay, because of same base, both also x. That means now we have to plus the degree. So here, x to the power of r plus negative 6 plus r. It will be x squared. So now I will just compare the degrees. 2 equals to r plus r will be 2r. Then plus times minus is minus 6. Therefore, from here, I will get 2r equals to 8 by moving the minus 6 to the left hand side. Then now my r is going to be 4, which means the term with the x squared happens when r equals to 4. Okay, so now I will write coefficient of x squared. So to get the coefficient of x squared, I have to substitute into all these terms. Alright, substitute the r equals to 4 into all these ticks, the green ticks. That means I will be getting 6c4, 2 to the power 4, a to the power 6 minus 4. So from here, you will be getting 240 a squared. Now, in the question it's mentioned that both coefficients are equal. Okay, so now means that I have to write 15 equals to this 240 a squared. So 15 equals to 240 a squared. That means the a squared is going to be 1 over 16. Now let's look at the question. The a is a positive constant. Therefore, from here, my a will be just 1 over 4. So that is the solution for this question. Now question number 2. The second and third terms of a geometric progression are 10 and 8 respectively. find the sum to infinity. So geometric progression. Second term is AR, the value is 10. Third term, it is AR squared, and the value is 8. So from here, I will solve simultaneous equations. So second equation divided by first equation. So when you divide, A cancel off, R squared over R will be just R. Okay, then 8 over 10. That means my R is going to be 0.8. Now to get the A, so from first, the A times 0.8 equals to 10. That means A is 10 divided by 0.8. Therefore, you'll be getting 12.5. Now, sum to infinity, formula is A over 1 minus R. Then I'll just replace 12.5 over 1 minus 0.8. That means I'm getting 12.5 divided by 0.2. And at last, you will be getting 62.5. So that's the solution for question number 2. Now for question number 3, the equation of a curve is such that given the dy dx is given that the curve passes through a point, find the equation of the curve. So for your information, if you are given y, right, to get dy dx, we differentiate. But then now you are given dy dx, to get back the y, it is a reverse process. That means this is integration. Right? So from here, my dy dx equals to 3 times 4x minus 7 to the power of half minus 4x to the power of negative half. So now my y is going to be integration of the dy dx. So when I integrate the first term, for your information, we are going to use this formula ax plus b to the power of n dx. That it will be ax plus b to the power of n plus 1 over n plus 1. Don't forget to differentiate ax plus b, it will be a. After that, plus c. So now, here I will get 3, remain the function. The degree half becomes 3 over 2, divided by 3 over 2, and differentiate the bracket, you will get 4. Okay, minus remainder 4, because the power negative half, the negative half is the power of x only, not for the 4x. So now when you integrate x power negative half plus 1 is half, then divided by half. After that, plus c. Okay, so from here, when you simplify, your y is going to be half. Okay, 3 divided by 3 over 2 times 4. This is basically half. So this can be simplified here too. So the 3 and 3 cancel off. Alright. So now I'll get half of 4x minus 7 to the power of 3 over 2. So 4 divided by half is basically 8. It's like 4 times 2. Then x power half I can change to square root x. After that, plus c. Okay, now to get the c, substitute this point. X is 4, y is 5 over 2. Which means now I will get 5 over 2 equals to half times 4x, x is 5 over 2, minus 7, then this whole term power 3 over 2, minus 8 square root 4 plus c. Okay, so from here, now I will be getting 5 over 2 on the left hand side. For the first two terms, these two terms, when I calculate one shot, it will be negative 5 over 2. Just press calculator. Okay, then plus c. Now my c is 5 over 2 plus 5 over 2. That means it's 5. Therefore, the equation of the curve is found. So just substitute the c value that you have just found into this equation. That will be the final answer. So we have solved this question. Let's move on to the next question. Now next question number 4. The first, second, and third terms of an arithmetic progression are k, 6k, and k plus 6, respectively. A. Find the value of the constant k. So now, arithmetic progression, first term is k, second term 6k, third term k plus 6. Alright, so from here we need to get the common difference. So the common difference is second term minus first term equals to third term minus second term. So for the left hand side I will get 5k. For the right hand side you will get 6 minus 5k. Okay, so now the negative 5k will be moved to the left hand side to be positive 5k, and then we add with the 5k on the left hand side, you will be getting 10k equals to 6. Therefore, my k is 6 over 10, which is 0.6. Okay, so that's the solution for A. Now B, find the sum of the first 30 terms. So I need to rewrite my AP, okay? So my AP, basically the first term is k, is given in the question here. So now my k is 0.6, which means now A is 0.6. Now my common difference, okay, now for your information, common difference is basically this. So it is also same as 5k. Alright, so now common difference is D. It is same as 5k, which means it's 5 times 0.6. Then you will be getting 3. Now we need to get S sum of the first 30 terms. So S30. Now for formula is Sn equals to n over 2a plus n minus 1 d. So now I direct replace the n by 30, which means I will be getting 30 over 2 bracket 2a plus 29d. Okay, so here I will get 30 over 2 times 0.6 plus 29 times 3. So you will be getting 1323. This is a sum of first 30 terms. So if you want to round up, this is the exact value, okay? So no need to round up to 3 significant figures. Okay, now question number 5. The equation of a curve is y equals to this quadratic function, and the equation of the line is y equals to x minus a, where k and a are constants. First part, given that the curve and the line intersect at the points with x coordinates 0 and 3 over 4, find the values of k and a. So since they are intersecting, means that you have to solve these two simultaneous equations. So now, first is a quadratic curve. This is the first equation. Then it is a straight line. Okay, so to solve the simultaneous equation, I can just say substitute first into second, which means I'm getting 4x squared minus kx plus 12k squared equals to x minus a. But then it's mentioned that the intersection points with x coordinates 0 and 3 over 4. So when x equals to 0, I will get, first term is 0, second term is 0, so I will get half k squared equals to 0 minus a, so minus a. Then from here, my a is negative half k squared. This is my third equation. Now, when x equals to 3 over 4, so 4 times 3 over 4 squared minus k times 3 over 4 plus half k squared equals to, the x is 3 over 4, then minus a. Then from here, right, I will substitute my a, the third, into the fourth. So now, this is the fourth. So third into fourth. Okay, so I will just rewrite, because I don't want to count first. I want to count all at the same time. this is going to be 3 over 4 minus, okay, minus is a plus, half k squared. So from here, I notice that the half k squared can be cancelled out from both sides because both are the same term, right? So now, from here, okay, I keep this, I move this to the right side to make it a positive. Then this 3 over 4 move to the left hand side. So when you minus, I will be getting 3 over 2, right? Which means 3 over 4k equals to 4 times 9 over 16 minus 3 over 4. So here you will get 3 over 2. Then at last, your k is going to be 3 over 2 times 4 over 3. Then the answer is 2. Okay, so once you have found the k value, to get the a, very simple, substitute into the third equation. So your a is negative half k squared. So from third, a is negative half k squared. That means from here, you'll be getting negative 2. So with this, we have solved this question. Right? So now, part B, given instead that a equals to negative 7 over 2, find the values of k, so more than 1k, for which the line is a tangent to the curve. So the tangent means there's only one intersection point. Right? So now I have to solve the simultaneous equations, which means I can refer to this equation, right, and replace the given a. So I will write 4x squared minus kx plus half k squared is x minus half. So from a, 4x squared minus kx plus half k squared equals to x minus a. So now given a equals to negative 7 over 2. That means this becomes 4x squared minus kx plus half k squared equals to x. Now, minus a, your a is minus, so minus minus is a plus. So plus 7 over 2. Okay, and now I will move all the terms to the left hand side. So 4x squared minus kx plus half k squared minus x minus 7 over 2 equals to 0. Now, for tangent, it will be one intersection point, or in other words, the discriminant equals to 0 because only one root. So that you will be getting one intersection point, which means now I need to rearrange this equation first so that it will be in the general quadratic equation form. So I will get 4 plus, it will be just one term with x squared. This is the only term. So it will be 4x squared. Okay, now the term with the x will be second and fourth term. So from here I may factorize the negative x. Right, so negative x bracket k plus 1. Then the remaining two terms will be grouped together. That will be our constant in the quadratic equation. So after you have obtained this, I will write down the coefficient for x squared, which is a equals to 4. B is the coefficient for x, which is negative of k plus 1. Then the c is going to be half k squared minus 7 over 2. Okay, since a line is a tangent, that means b squared minus 4ac equals to 0. There's only one real root for this equation. So now, negative of k plus 1 squared minus 4a. A is 4. C is half k squared minus 7 over 2. Then equals to 0. So from here, I need to get k values. You see, 2k values. Right, values of k means more than 1k. So when I do expansion, square of minus is positive. Now, for the quadratic expansion, a plus b squared is going to be a squared plus 2ab plus b squared. Which means now, you will be getting k squared plus 2k plus 1. Because the minus you square it becomes positive already. Then now, Okay, for the next one, you will just do expansion. Okay, so 4 times 4 is 16. 16 times half, it will be 8. So minus 8k squared. So now, negative 4 times 4 minus 16 times negative 7 over 2, you will be getting plus 56 equals to 0. So here is just to do expansion. Expand, expand. Now, again, simplify. K squared minus 8k squared, you'll be getting negative 7k squared. Then 2k positive. 1 plus 56 is plus 57 equals to 0. Then from here, I can times the whole equation by negative in order to get positive k squared or positive 7k squared. So I will get 7k squared minus 2k minus 57 equals to 0. Right? And then from this quadratic equation, I will factorize. So when I factorize, it will be k minus 3 and 7k plus 19. That equals to 0. So now either k minus 7 equals to 0, sorry, k minus 3 equals to 0, or 7k plus 19 equals to 0. Because we need to get product of two terms equals to 0 means one of the terms must be 0. Which means now the k is 3 or 7k is negative 19, which means the k equals to negative 19 over 7. So when look at the question, find the values of k means that more than 1k. Therefore, your final answer will be k equals to 3 or negative 19 over 7. So that's the solution of this question. Okay. Now for question number 6. The diagram shows the curve with equation y equals to 5x degree half and the straight line y equals to 2x plus 2. Okay. Now find the exact area of the shaded region which is bounded by the line and the curve. So firstly, we need to find the intersection points. So there are two intersection points here. So the intersection points is found using by solving the simultaneous equations. So when we need to solve these simultaneous equations, I will just let first equals to second, okay, or first substituted into second equation. So I will get 2x plus 2 equals to 5 square root x. But since there's a square root x there, I need to square both sides to eliminate the square root. And then again, for the left hand side, we do expansion, quadratic expansion. It will be 4x squared plus 8x plus 4. Then for the right hand side, square of 5 is 25. Square of square root x is just x. Now move the 25x to the left hand side. Okay, then you will be getting 4x squared. Now 8x minus 25x, it will be minus 17x. Then plus 4 equals to 0. Solve this quadratic equation by factorizing the equations into two linear factors. Then you will get x minus 4 times 4x minus 1 equals to 0. Then from here, either x minus 4 equals to 0 or 4x minus 1 equals to 0. Then from here, I will get x equals to 4 or x equals to 1 over 4. Okay, now I found two intersection points, 1 over 4 and 4. That means here 1 over 4 and this is 4. So now to get the exact area of the shaded region, it's obviously the region is towards the x-axis. Okay, so now if I integrate the curve from 1 over 4 to 4 means that I'm getting all this blue arrow. Then now I have to minus the green arrow here. Okay, so if you realize that when you minus a green arrow, right, that will be the shaded region. Okay, so it means that I have to integrate my curve minus the line from the x from 1 over 4 to 4. Okay, so that is the idea for getting the area of the shaded region. So I will show it over here. So now area of shaded region equals to integrate from 1 over 4 to 4, the curve, okay, because the curve is higher, curve minus straight line. So 5x degree half minus 2x plus 2 dx. So when you do integration, we always plus 1 degree to the x. So now x degree half becomes x degree 3 over 2 divided by the new degree. Then minus the 2x becomes 2x squared over 2. Then this minus you bring in, it becomes minus 2. So integrate minus 2 is 2x. Now with limits, add on the limits. Okay, so 5 divided by 3 over 2 from the first term is basically 10 over 3. I will rewrite. Then this is x degree 3 over 2. Now 2 over 2 is 1, so x squared minus 2x. So I simplify the terms first before I replace the limits. Okay, and then now just need to replace the x by 4. So 10 over 3, 4 to the power of 3 over 2 minus 4 squared, then minus 2 times 4. All of these terms minus when the x is 1 over 4. Okay, because of the lower limit. So this 1 over 4 will move up, or will be substituted into the x values now. So here will be 10 over 3, 1 over 4 to the power of 3 over 2 minus 1 over 4 squared minus 2 times 1 over 4. Okay, so from here, when you calculate the first square bracket, you will be getting 8 over 3. Then minus the second bracket here, this second bracket, it will be negative 7 over 48. So at last, you will be getting 45 over 16. So that is the exact area of the shaded region. Okay, question number 7. The diagram shows a sector OABC, OBAC of a circle with center O and the radius 10. That means OB is 10, OA is 10, OC is also 10. The points P lies on OC and BC, and BP is perpendicular to OC. Okay, angle AOC is 1 over 6 pi, and the length of the arc AB is 2. Here is 2. Alright, now find the angle BOC. Where is BOC? BOC is here. Okay, now we need to find this angle first by using this arc length 2. Okay, so BOA. Now, arc length formula is theta r. So now 2 equals to theta is BOA. Okay, angle BOA. Angle BOA. Multiply with the r. R is 10 because it is the radius 10. Okay, OB is 10. So from here, I will get angle BOA equals to 2 over 10, which is 1 over 5. Okay, so now we need to find angle BOC. So obviously, your angle BOC, the blue line, the blue angle is a green angle, which is a BOA plus pi over 6. So just plus both together. So angle BOC is angle BOA plus angle AOC. Which means this is 1 over 5 plus 1 over 6 pi. Okay, so if you want to get the same denominator, make it to over 30. So the first one becomes 6 and the second one is 5 pi. So that is the angle BOC. Now, B. Hence means use the previous angle that we have found. Find the area of the shaded region BPC, giving your answer correct to 3 significant figures. So where is the shaded region? Okay, so obviously the shaded region is area of this sector, which is BOC, minus area of the triangle BOP. Okay, so now for the triangle BOP, I need to know the length. Alright, so I need to know what is the OP. Look at here. You have two methods to find the area of triangle. Since this is triangle, either you know this A, this B, right? Means that this is OP, this is B. You know the length of OP and BP, then you can just use half OP BP. But unfortunately, these two are not known, right? So another option is, since we know this angle BOP, then I will just use half OB OP sine the angle, because we have a formula here. Let's say here is AB, this is theta. Your area is half AB sine theta. Okay, that is the formula for area of a triangle. So I'm going to use the second formula because OB is 10. I just need to find what is my OP. Okay, so the OP can be found using the angle. Look at here. I know what is this angle. We have just found it. So OP is the adjacent side and the OB is the hypotenuse. So adjacent and hypotenuse means the cos theta. Cos of this angle will be OP over OB. Then from there I can find the OP already. Alright, so I will start with using the cos angle BOP equals to BOP equals to OP over OB. So OP over OB. Alright, so now cos the angle already found just now, 6 plus 5 pi over 10 over 30 equals to OP. OB is 10. So from here, my OP is getting 10 cos 6 plus 5 pi over 30. Now, when you calculate, make sure this is in radians mode. Okay, so then you will be getting the answer as 7.4943. Here I give more significant figures because this is the working. Okay, so now my area of the shaded region equals to area of sector. So sector BOC, okay, the big sector. So sector BOC minus area of triangle. The triangle is BOP. Now, area of sector, basically it is half r squared theta. Let's say this is the sector. Alright, so from here, area of sector BOC, I have to use this whole angle together with the 10. Alright, so means that it will be half r is 10, so 10 squared. The theta is 6 plus 5 pi over 30. Minus area of triangle will be half. Look at the diagram. Area of triangle is half 10 OP sine angle. Okay, so I will get half times 10 times OP. My OP is this 7.4943, then sine of the angle. So When you calculate all this, okay, the first one is going to be 36.17994. I give more decimal places here. Now, the next one is going to be 24.80935. Now, look at the final answer. It will be correct to 3 significant figures. So now you calculate and round up. I will get 11.4. So that is the area of the shaded region. Okay, so next question, number 8. The equation of a circle is this. The points A and B lie on the circle. Find the values of A and B. That's the first part. And hence, so means that after you have found A, B, find the coordinates of the center of the circle. So we have two parts here. Now, I will just copy the equation of the circle first. Since both points lie on the circle, means that we can just substitute the coordinates into the equation of the circle. So at A, 1, 1 means x is 1, y is 1. So 1 squared plus 1 squared plus A times 1 plus B times 1 minus 12 equals to 0. Okay, so from here, I will get A plus B equals to 10. I move the numbers to the other side. Now, at point B, with coordinates 2 and minus 6, remember, your 2 is x, your y is minus 6. Therefore, from here, I will get 2 squared plus minus 6 squared plus A times 2 plus B times y. Y is minus 6. Then minus 12 equals to 0. Alright, so when I do expansion, the first term is 4. Second term is 36. Then 2A minus 6B minus 12 equals to 0. Now, you can simplify this. So I keep the A and B on left hand side, then the rest will be moved to right side. So obviously from here, this is 40. 40 minus 12, you will get 28. So the 28 moved to the other side becomes negative 28. And I notice that these three terms can be divided by 2. Okay, then you will get A minus 3B equals to negative 14. This is the second equation. Now, to solve these two simultaneous equations, I will use first equation minus second equation because I get the same term of the A. So A minus A will be 0. B minus minus 3B, it will be 4B. Okay, the equal sign is the same. So 10 minus minus 14 is 24. Then from here, my B is 6. After you found the B, to get the A, just substitute into first or second equation. So I substitute into first equation. So A plus B. So B replaced by 6 equals to 10. So obviously your A is 4. Okay, so with this, I have found the first part. A and B done. Now hence, find the center, the coordinates of the center. So now, I have to rewrite. Okay, substitute into here. So x squared plus y squared. Then plus ax. The a is 4. So plus 4x. After that, plus by. Now your b is 6. So plus 6y. Then minus 12 equals to 0. So to get the center, we need to complete the square. Okay, so I rearrange first. X squared plus 4x, then plus y squared plus 6y. The 12 move to the other side. Then now complete the square because the general equation of the circle is x minus a squared plus y minus b squared equals to r squared. This is the equation of a circle. Then once you have written this, the center will with coordinates of AB. Okay, and the radius is R. So now I need to make it to this form. That means I have to complete the square. So complete the square means x squared plus 4x. then plus 4 over 2 squared minus 4 over 2 squared. This is from the first bracket, x squared plus 4x. And then for the second term, same case, y squared plus 6y, then plus half of the plus 6, it will be 6 over 2 squared minus 6 over 2 squared, then equals to 12. Then from here, okay, I will group the first and last term, it will be x plus 2 squared. Then minus, I know that this is 2, 2 squared is 4, so minus 4, plus, now for the y is the same, group the first and last term, so you will get y plus 3 squared, because 6 over 2 is 3, okay, then here is going to be minus 3 squared, so minus 9 equals to 12, then I will get x plus 2 squared plus y plus 3 squared, so minus 4 and minus 9 is minus 13. You move to the other side, equals to 25. That means now I will get x minus minus 2 squared plus y minus minus 3 squared equals to 5 squared. Okay, which means the circle with center minus 2 minus 3, and then the radius is 5. Okay, so because the question is asking for center coordinates, right? Therefore, you can just write, therefore, center of the circle equals to -2, -3. Right? So that is the solution for this question. Okay, now B. Find the equation of the tangent to the circle at the point A, giving your answer in the form px plus qy equals to k, where p, q, and k are integers. So now, equation of the tangent at circle. Okay, so when you see tangent, you may use dy dx. Alright? Because the dy dx is referring to the gradient of the tangent. So now, I can refer to this form. Okay, since I have solved it here, I can refer to this form. Alright? And then I will get my dy dx. Okay, so you have two methods to solve. If you want to use this equation, you can start from the beginning and differentiate. So we have two methods. Maybe I just show you two methods. Alright, so first of all, I copy back and differentiate. This is your circle equation. Now you can directly differentiate. So differentiate x squared, it will be 2x. Differentiate y squared is 2y dy over dx, because we have a formula here. Differentiate fy with respect to x. It will be differentiate fy with respect to y, then you times dy over dx. That's why when I differentiate y squared with respect to y, I'm getting 2y. Then just times dy dx. So this is the chain rule. Then plus differentiate 4x is 4. So differentiate 6y with respect to y, it will be 6. Then you times dy over dx. The negative 12 becomes 0 because no x. Okay, so now at the point A. So after you get this, you can just directly replace the point A coordinates. The point A is with coordinates 1, 1. So now I will substitute x by 1 and y by 1. So when I replace, 2 times 1 is 2. Alright, so I substitute into this equation. Then 2y again is 2. Then dy dx plus 4 plus 6 dy over dx equals to 0. Now 2 dy dx plus 6 dy dx is 8 dy dx. And then this plus 2 and plus 4 will be plus 6. You move it to the right side, becomes minus 6. Now from here, my dy dx is minus 6 over 8, which is minus 3 over 4. So I have found the gradients of the tangent. So for your information, tangent is a straight line. Okay, so once you have found this, then I can just form the tangent line. I will write equation of tangent at A. So the formula is y minus y1 equals to m bracket x minus x1. So now my y1 is 1, my x1 is 1. So y minus 1 equals to the m is negative 3 over 4. So x minus 1. Okay, then from here, it will be negative 3 over 4x. This one times in, it will be plus 3 over 4. And this minus 1, you move to the right side, becomes plus 1. Then I will be getting y on the left hand side. Which means final answer, your y is negative 3 over 4x. So 3 over 4 plus 1 is basically 7 over 4. So this is the equation of the tangent at A. Okay, this is by differentiating directly the equation of the circle. Now, another method is you can just use the previous form, okay, which means you refer to this form. Alright, so I will rewrite x plus 2 squared plus y plus 3 squared equals to 25. From here, I can get the y as a subject. So y plus 3 squared equals to 25 minus x plus 2 squared. Then my y is going to be y plus 3 equals to square root. Okay, and then the plus 3 move to the other side, becomes minus 3. Okay, now differentiate. So you can change this to degree half. Change the first term to degree half first. So now my dy dx, but you need to differentiate this form, right? So differentiate fx to the power of n. It will be n fx to the power of n minus 1, then f prime x. This is a power rule. Okay, so now when I differentiate using this power rule, I bring down the half, rewrite the whole bracket. The degree becomes minus half because you're minus 1. And now you differentiate the bracket. Differentiate 25 is 0. So negative and again squared, right? Bring down the negative 2. Bring down the 2 and combine with the negative. Then keep the x plus 2, degree 1. And differentiate the bracket, it will be 1. Then minus 3. Alright, so from here, I can simplify. The half and 2 cancel off. Okay, and then now you substitute the points A, because we need to find the gradients at the points A. A is 1, 1. So now I will write at A 1, 1 dy dx is, this is 1 plus 2 is 3, and there is a negative there. So I will write negative 3. Then because of the negative power here, I will write over square root. Okay, so there's a negative. This is half, this is 2. Now I will write 25 minus 1 plus 2 is 3 squared. Then minus another 3. So from here you get negative 3 over 25 minus 9. You will get 25 minus 9, 16. Then it will be negative 3 over 4, then minus 3. And at last you will get, okay, wait, let me check. Oh, I made a mistake. So here, look at here, shouldn't have negative 3, because this is your y, this is your y. When I differentiate, this minus 3 is a constant, should be 0 at the back. Okay, I overlook it. So here, no more minus 3. Alright, so you will get just minus 3 over 4. So this negative 3 over 4 is same as just now. Okay, so after you get this step, then you just repeat the, okay, after you get this step, then you just repeat this straight line steps. Okay, here I only show you the alternative to get the dy dx. Clear? Alright, so now for question number 9, given the y where the x greater than negative 1 over 3, find dy dx and d squared y over dx squared. So my y is 3x plus 1 minus 4 times 3x plus 1 to the power of half. So now my dy over dx, it will be, differentiate 3x is 3, differentiate plus 1 is 0 because no x. Now again, this half you bring it down. So negative 4 times half, this is by power rule, then 3x plus 1. Now the degree half you minus 1, so half minus 1 is negative half. Then after that, differentiate the bracket. So when differentiate 3x plus 1 is 3. So now I simplify first, because I need to get this dy dx and d squared y over dx squared. Then this part cancel off, becomes 2. This 2 and 3 becomes 6. So I will get 3 minus 6 bracket 3x plus 1 to the power of negative half. So this is my dy over dx. Okay, now d squared y over dx squared. First term without x, when differentiate you get 0. Rewrite the minus 6. The minus half, the power negative half, bring it down according to the power rule. Then rewrite 3x plus 1. The degree, instead of minus half, now you minus 1. So minus half minus 1 becomes minus 3 over 2. Okay, and don't forget to differentiate the bracket. So you will be getting 3. Now we just need to simplify. Okay, so from here, minus 6 times minus half, it will be 3. This 3 together with the 3 at the back becomes 9. So I will get 9 times 3x plus 1 to the power of negative 3 over 2. So this is your d squared y over dx squared. B. Find the coordinates of the stationary points of the curve and determine its nature. So now, stationary points happens when dy dx equals to 0. So now I will just copy my dy dx from the previous part, which is 3 minus 6 degree negative half of 3x plus 1. So 3 minus 6, then 3x plus 1 to the power of negative half. To solve this equation, it's better to move down the 3x plus 1 to the power of half, because there's a negative degree there. So I will change to 3 minus 6 over square root 3x plus 1. Then equals to 0. So I will move the whole negative to the right side. It will be 3 equals to 6 over square root of 3x plus 1. Okay, then the square root move up, the 3 move down. So 6 over 3 is 2. Alright, so now to eliminate the square root, I have to square both sides. So when you square both sides, the left hand side becomes 3x plus 1, right hand side is 4. So from here, 3x equals to 3, therefore x is 1. But then the question says, find the coordinates of the point, which means we need to find the y value. Okay, so now rewrite the y value, which is 3x plus 1 plus 4 square root 3x plus 1. That's the y. So the y equals to 3x plus 1 minus 4 square root 3x plus 1. Okay, let me check first before I proceed. Alright. So now replace the x by 1. So at x equals to 1, the y is 3 times 1 plus 1 minus 4 square root 3 times 1 plus 1. So 3 times 1 plus 1 is basically 4. So minus 4 square root 4. So 4 square root 4 is 8. So 4 minus 8, it will be minus 4. Okay, therefore, stationary point equals to x is 1, y is negative 4. So that's the first part of the question. Now, after you have found the stationary point, you need to determine the nature. The nature is decided by referring to the second derivative. So now my second derivative is 9 times 3x plus 1 to the power of negative 3 over 2. So d square y over dx square is 9 times 3x plus 1 to the power of negative 3 over 2. So again, it depends on the x. So now I have to substitute the x is 1. So when x equals to 1, d square y over dx squared is 9 bracket 3. My x is 1, then plus 1 to the power of negative 3 over 2. That means this is 9 times 4 to the power of negative 3 over 2. So when you calculate this value, it's going to be 9 over 8. So 9 over 8 is greater than 0. That means the stationary point is actually a minimum point. So 1, negative 4 is a minimum point. Okay, so we have solved this question. For question number 10, given fx is 2x plus 1 over 2x minus 1, whereby the x cannot be half, gx is x squared plus 4, x is real number. Now, A, the graph is given. The graph shows the parts of y equals fx. State the domain of f inverse. Okay, so now we know that domain of f inverse equals to range of f. Since the graph is given, so obviously your range means the y values. It can be any numbers except y equals to 1 because it never touched y equals to 1. Okay, so I will just write range f is fx is real number because it can be extended to negative and positive infinity for the graph. Alright, except fx equals to 1. Okay, means that fx cannot be 1. So due to this reason, domain f inverse is range f. Therefore, my domain f inverse, domain is referring to the x. So I will just copy these two results, but change the fx into x. Okay, change it to x because we are finding the domain right now. So it will be x is real number, but x cannot be 1. So that's the domain of f inverse. Now, find an expression for f inverse. So now I need to copy this. Fx is 2x plus 1 over 2x minus 1. So I will let y be fx. That means my y is going to be 2x plus 1 over 2x minus 1. Now to get the f inverse, the concept is you just rearrange this expression so that the x is the subject. Alright, so now I have to times the 2x minus 1 to the left hand side. Then I will get 2xy minus y for the left hand side equals to 2x plus 1 on the right hand side. And then I need to get the x as a subject, which means this 2x I move to the left side, the minus y I move to the right side. So I'll get 2xy minus 2x equals to y plus 1. Then for the left hand side, the common is the x, right? 2x. So I will write 2x bracket y minus 1 equals to y plus 1. I need to get the x as a subject, so the 2 brackets y minus 1 will be moved down. So I will get y plus 1 divided by 2 brackets y minus 1. So at last, your f inverse just change the x to f inverse, change the y to the x. So I will get x plus 1 divided by 2 times x minus 1. So this is my solution. Okay. So now see, find GF inverse 3. So I can find F inverse 3 first. So F inverse 3 equals to, just replace the x by 3. So 3 plus 1 over 2 bracket 3 minus 1. That means you're getting 4 over 2 bracket 2. So it is 1. So therefore GF inverse 3 is same as G1. So now substitute the x by 1. Okay, so replace the x by 1. I said replace the x by 1. So it will be 1 squared plus 4. It will be 1 squared plus 4. Therefore, you are getting 5. So that's the solution for part C. D. Explain why G inverse cannot be found. Okay, now let's look at the G inverse graph. So, let's look at the GX graph or GX function. When you look at the GX, this is a quadratic function. So quadratic function, by looking at the domain here, means that when you draw the graph, when x is 0, your y is 4. That means here is 4. Okay, this is x. This is your GX. This is a y-axis. So for this domain, obviously it is not one-to-one mapping, because, or it is not one-to-one function, because when you draw a horizontal line along the, which is parallel to the x-axis, it has 2 intersection points. Right? That's the reason the G inverse does not exist. Okay, so now I will just explain here. G inverse cannot be found because Gx is not one-to-one function. Alright, so that's the reason for the non-existence of inverse function for the G. Okay, so now let's solve the E. Show that 1 plus 2 over 2x minus 1 can be expressed as this form. Hence, find the area of the triangle enclosed by the tangent to the curve at the points where x equals to 1 and x equals to x and y axis. Okay, so from here, firstly, show it can be expressed in that form first. 1 plus 2 over 2x minus 1 is the same as getting the same denominator. So 1 times 2x minus 1 plus 2. Then here is basically 2x minus 1 plus 2 is plus 1. Okay, already done. Now, equation of tangent. See, equation of tangent. So now, equation of tangent of y equals to fx at x equals to 1. So now, what is your fx first? Go back to the question. Your fx is 2x plus 1 over 2x minus 1. Okay, so just now, you have proven that this can be expressed in this. So it means that your y equals to fx, which is 2x plus 1 over 2x minus 1, which is same as 1 plus 2 over 2x minus 1. Then this is also same as 1 plus 2 bracket 2x minus 1 to the power of negative 1. Okay, so in order to get equation of tangent, we need to get differentiation, which is a gradient of tangent. So now my dy dx will based on this expression. So when I differentiate 1, I'll get 0. So now remainder 2, bring down the negative 1, then rewrite the bracket. The power minus 1 becomes minus 2 because you keep minusing by 1. Then differentiate the brackets, 2x minus 1 becomes 2. So from here, I will get minus 4 bracket 2x minus 1 to the power of negative 2. And since the power is negative, I can bring it down. It will be negative 4 over 2x minus 1 squared. Okay, now at x equals to 1, what is the dy dx? The gradient. So now, when x equals to 1, my dy dx is negative 4 over 2 times 1 minus 1 is 1. So 1 squared. That means the gradient is negative 4. Okay, and when you look at the previous calculation, have we solved or we haven't solved yet? Okay, now when x equals to 1, what is the y? Right, because we need to get the equation of tangent. So when x equals to 1, the y, which is fx, is going to be 2x plus 1 over 2x minus 1. So 2x plus 1 over 2x minus 1. That means you are getting 3 over 1, which is 3. So the point is with coordinates 1, 3. Okay, so now I can find the equation of tangent. So equation of tangent of y equals to fx at x equals to 1. Okay, it will be y minus y1 equals to m bracket x minus x1. So the m is minus 4 and use the point 1, 3. So now I will be getting y minus 3 equals to negative 4 of x minus 1. Then I will get negative 4x. Here is plus 4. Then move the minus 3 to there, becomes plus 7. Okay, now we have found the equation of the tangent. But then the question says, you need to find area of triangle enclosed by the tangent to the curve where x equals to 1. Okay, done already. And the x-axis, y-axis. So now when you look at this graph, okay, so when x equals to 1, right? So tangent line means like this, isn't it? It touches one point. Then you'll be getting a triangle. And now you need to find what is this area. Okay, so which means now I need to find for this tangent line that we have found, what are these 2 points? After I found, then I can just find area of the triangle. So for this line, for first, okay, so from first, when the x equals to 0, my y is 7. When my y equals to 0, right, 0 is negative 4x plus 7, which means 4x equals to 7, or x equals to 7 over 4. So now I will label these 2 points on the diagram. So 0, 7, 7 over 4, 0. So 0, 7. That means here is 7. Here is 7 over 4. So if you need to find area of this triangle, okay, obviously is half times 7 times 7 over 4. That's the area. So now I will just write area of the triangle equals to half times 7 times 7 over 4. Then it will be 49 over 8 units squared. Okay, so that's the solution of this question. Okay, now for question 11, the function f is given by this, where the x is defined from 0 to 2 pi and the k is a constant. A, given that k equals to 3, find the exact solutions of the equation. So when k equals to 3, fx equals to 4 cos degree 4x plus cos square x, k is 3 minus 3. Okay, when it is 0, so 0 is 4 cos degree 4x plus cos square x minus 3. So from here, I get the quadratic equation. okay, in terms of cos square x. So I can factorize this. So you just assume u is cos square x. That means cos power 4x is a u squared, right? So when you factorize using quadratic, the built-in function in your calculator, the quadratic equation, then you will get 4 cos square x minus 3, then cos square x plus 1. Then from here, either the first bracket equals to 0 or second bracket equals to 0. Alright, so for the first term, I will get cos square x. So move the minus 3 to the other side, means it's 3. But then this belongs to 4 cos square x. So I need to get 1 cos square x, therefore divide by 4. So it will be 3 over 4. Then, now, for the other, or on the other side, the cos square x plus 1 equals to 0 means that cos square x equals to minus 1. But we know that cos square cannot be negative. Here, no solution. Okay, then now cos square x is 3 over 4 means that your cos x is plus minus square root 3 over 4, which will be plus minus square root 3 over 2. Now, when you refer to the domain here, 0 to 2 pi, and you need to get exact solution, means that in terms of, no decimal. So therefore, I will just refer to the quadrant diagram. Since your cos is plus minus, means you have to consider all 4 quadrants right now. So when you get the basic angle, x is at cos square root 3 over 2, you will be getting pi over 6. That means all this will be pi over 6. Right? So I leave my answer in pi because the domain is in pi, in radians. So basically, your first angle is pi over 6. This is your second angle, third angle, and fourth angle. Okay? So now I will get x is pi over 6. The second angle is pi minus pi over 6. Third angle is pi plus pi over 6. And last angle 2 pi minus pi over 6. Then you will be getting pi over 6, 5 over 6 pi, 7 over 6 pi, and 11 over 6 pi. Okay, so that's the solution for this question. Now, B. Use the quadratic formula to show that when k greater than 5, the equation has no root. So now, when fx equals to 0, okay, rewrite, it will be cos power 4x plus cos square x minus k equals to 0. So now, your quadratic formula is basically ax squared plus bx plus c equals to 0. Your x is minus b plus minus square root of b squared minus 4ac over 2a. So we follow here. This is x, which means now my x has been changed to cos square x. Okay, so my a is 4, my b is 1, and my c is minus k. At the same time, my x has been changed to cos square x. So I will write cos square x equals to minus b, so minus 1, plus minus square root of b squared minus 4ac over 2a. So here you will be getting minus 1 plus minus square root of 1 square is 1, minus 4 times 4, minus 16. Minus 16 times minus k, it will be plus 16k, then over 8. Now, from here, we cannot accept the minus sign, okay? Because if you accept the minus sign, out of the plus minus, you will be getting a negative value for the cos square x. So from here, I know that cos square x is going to be minus 1 plus square root 1 plus 16k over 8. Okay, now, we need to show that when k greater than 5, there's no solution. So I have to calculate when k equals to 5, what happened? So cos square x is minus 1 plus square root of 1 plus 16 times 5 over 8. This is going to be minus 1 plus square root of 81 over 8. then when you count the value, it will be 1. Okay, then now when k is greater than 5, square root of 1 plus 16k is greater than square root of 81. That means it's greater than 9. Okay, just for this part, this is greater than 9. And then now when you substitute into cos square x, so my cos square x will be minus 1 plus square root 1 plus 16k over 8. So since this is greater than 9, okay, so minus 1 plus a value greater than 9, that means it will be greater than 8, right? So when greater than 8 divided by 8, it will be greater than 1. So here will be greater than 1 because, right, square root 1 plus 16k is greater than 9. So minus 1 plus square root 1 plus 16k is greater than minus 1 plus 9. Therefore, it's greater than 8. So when greater than 8, you divide by 8, it will be greater than 1. So when cos square x greater than 1, that is no solution. Okay, this one no solution. Because we know that cos x in between minus 1 and 1. So when cos square x is also in between minus 1 and 1. Alright, so that's why when your k is greater than 5, there's no solution for your fx equals to 0. Okay, so k greater than 5, no solution for fx equals to 0. So this is how we show it. Okay, now we have come to the end of the video. Thanks for watching. If you enjoy watching my video, please subscribe to my channel and recommend this channel to your friends. Okay, not to forget to stay tuned for the upcoming videos as well. Thank you. Bye.